And I think probably, it would be good to get a sense of, how many new people are there so that, I can probably figure out, if there is, some information from yesterday where I just need to spend a little bit less time, given that, it's the same audience, but if there are, fair bit of new people, then it would make sense to actually stress on each of the points we stressed yesterday as well when we did a high level overview through these. So if you are, if you weren't here yesterday, right, definitely ping it on the chat. And by the way, I'll get started, right? So essentially, I think without doubt, Kubeflow pipeline is the most popular component in the Kubeflow umbrella. And this is something which came out around the last quarter of 2018, at least the initial version. And since then, the adoption has increased heavily. And I think the main premise of Kubeflow pipelines has been, handling what is emerging as the MLOps paradigm, where essentially, we are getting to a place where data scientists are expected to do more, right? I think there has been a notion that data scientists understand Python. They will give you an initial model. Here is my Python code. Go and figure out how to move it in production, right? That is changing rapidly. And part of the reason is, more and more models are moving in production. With more and more models moving in production, right, you're iteratively producing new versions of the models. So the fact that, hey, here is my Python code, go and figure out how to run in production doesn't work, right? We cannot have those strong boundaries where, and we have our own experiences in the past where we have been handed, here is my Jupyter notebook, here is the model embedded in the Jupyter notebook, just run it in production. It's ready. And it's then, 3 months after the fact, to get that real ready running in production, right? So one of the Jupyter notebooks, for example, we were handed was a scikit-learn model doing, processing using Spark on a data. And then, after it pre-processes the data, then it pushes to Kafka, etc. And when you actually are setting up an environment like that in production, running on top of your Kubernetes, OpenShift platforms, or another cloud native provider, which you choose, right? To get that all going and having that work, when you're assuming, it's a instance of Spark SQL running on your laptop versus, when you have a real production deployment in Spark, for example, or Kafka, things typically change, right? And change a lot. So that was the notion that, data scientists will be required to go a step further, right? Not here is my Python code, but technically, okay, I have developed it and I have now, also validated it and deployed it in some sort of semi-staging environment where it is running, right? That's probably the handoff expected. So to go and take them to the next steps, right, there was an automation needed, but that automation had to be friendly to them, right? You should be able to converse in the same language. So that was one premise. The second part was, bringing the MLOps or the DevOps folks who are infrastructure providers on these side on the same page. Okay, I am running these models, training them, validating them. And now since you're moving in production, you are using the same infrastructure, right? The same language to talk to each other. So hence, something like Kubeflow pipelines has become very, very relevant in the machine learning space. And then the third angle, which probably a lot of us don't talk much, but is equally important, and in fact, in a lot of sense, more important, is the relevance of the artifacts or lineage tracking in context of machine learning, right? I think we have stressed enough yesterday as we talked that given the experimental nature of it, you will be running these many times. If you're running these many times, you're producing multiple artifacts, your changed data sets, your changed models, your hyperparameters, and you need a way to track them. You need a way to trace the lineage when your models are, deployed in production and giving results, right, for auditability, or, just in case somebody comes and tells you, hey, from your audit department that this model is giving, totally awful predictions, right? So I think all these reasons bring data scientists and DevOps folks together on the same page, enable data scientists to go steps further. Just don't give me your Python code. And the metadata lineage tracking, right, that led to the rise of the machine learning pipelines. Um, and so one of the things Kubeflow pipeline did right at the outset was start speaking the same language. So there was a Python DSL which was crafted, and then there was a dashboard built on top of CI/CD tooling engine called Argo, right, to actually orchestrate this end to end. And the third thing is, a lot of the Kubernetes paradigms, right, Kubernetes volumes, config maps, secrets, they're all exposed through that DSL in Python-centric way, right? So you are leveraging the underlying constructs of Kubernetes volumes or config maps or secrets, etc., but using, your familiar Python to interact with them. I think this is DSL, which we typically use because it shows and covers also the data part of the life cycle. Quite a few questions I think from yesterday was also right. Can Kubeflow also cover data part of the life cycle, right? So and part of that answer was depends, right, depending on your components. So right, in this case, for example, if you see this is a pipeline which is using TensorFlow extended components, right? So it's a Kubeflow pipeline, but using TensorFlow extended components like TFDV, TensorFlow data validation to do data validation, right? There is a component in Kubeflow, TFX for data pre-processing, right? There are components for schema generation. So you can leverage all those components through Kubeflow pipeline, right? So, and most of the TFX components have been integrated as a first-class citizen, but that doesn't stop you from bringing your own custom component, right? So now if you look at it, this is 15 lines of DSL approximately, but going through the whole end-to-end life cycle, right? Doing data validation, pre-processing, doing distributed training, analyzing the model produced after the distributed training, and then finally deploying it. Now, once you have the DSL and you've compiled, you can upload and run, and you can also inject your custom metrics, right? So a lot of the data scientists understand, the statistical graphs, the ROC curves, or for example, you're using TensorBoard, right? So a lot of them, by a virtue of, this plugin mechanism you can have as integrated as part of your pipeline, right, when you're running. So you can look at the TensorBoard metrics, or you can, inject your own ROC curves, which you're displaying, etc. I think this is probably very straightforward to understand. We will be running these pipelines more and more and more, and we need a very robust versioning mechanism, right? Artifact tracking cannot be stressed enough, the importance of it. Once you get through the initial excitement of running pipelines and are doing something serious, you will require this. And trust me, I mean, we have, seen this happening in prod environments where, the need to go back and figure out the artifacts which have been produced, looking into the details of them, looking where they are stored, right? And not only that, the next step, which is, the lineage tracking, which is, I would say, the most important probably in your prod environments, and that lends itself also to a lot of compliance and tracking and auditability issues, which you will need when you are rolling these models in production, right? You need to have a way to do lineage tracking, right? You need to be able to trace back all the way to the data set, to the hyperparameters used, to the version of that whatever framework was chosen to train this model, what was the distribution of the training data set and scoring data set, for example, right? So all that information, it gets tracked as part of your pipelines, as part of the lineage tracking graph. So this is the high-level architecture. One of the key things, right, which is happening in the community. So when you look at it as an entry point, right, the first entry point is obviously the SDK, right, which allows you to compile a Python DSL which you have written to a format which the Kubeflow pipeline engine will understand. Now, there is also TensorFlow extended or TFX pipelines, right, which are more, in fact, more exclusive to the TensorFlow community, right? But what is happening as Kubeflow pipeline is progressing is that, both of these SDKs will be merged in one. But for now, you can also use TFX SDK, and you can choose there that I want Kubeflow pipeline as a backend. So you can come through TFX SDK, but the primary means what community uses is the Kubeflow pipeline SDK to craft these pipelines and then compile it to the format which Kubeflow pipelines engine understands, right? And then those SDKs are the ones which are mostly being used in the notebooks throughout for defining these pipelines. The engine itself, under the covers, there is S3 backed object storage, which by default is Manio, but you can configure it to any scalable backend S3 compatible object storage on your favorite cloud provider. There is the metadata store, MLMD. There is the MySQL database, which holds all the relationships between the pipelines, experiments, and runs, right? And there is an API engine and as well as a UI. Now there are a lot of pipelines which you will see which are pre-configured to not only use Kubeflow components, right? So if you're running totally all native open source, there are pipelines where you can use Kubeflow components for distributed training, model serving, etc. But if you are running your workloads on, let's say, Watson portfolio, right? If you're using Watson Studio for distributed training, Watson machine learning for your model serving, OpenScale for model quality metrics monitoring, for drift detection, etc., right? You can use pipelines, Kubeflow pipelines, but with those backend engine providers. Similarly, if you're running on AWS, there are pipelines, right, with backend for SageMaker, etc. Now, if you look at much deeper into this architecture, there are a lot of things going on, right, vis-a-vis to ensure that there is a smooth orchestration. I think for the most part, bulk of the heavy lifting, right, which is running your core jobs and monitoring them, is performed by the underlying CI/CD engine, right? Whether it's Argo or one of the things which we'll talk about, Tekton, under the covers. But then there is a lot of the capabilities on top, and right now one of the efforts also which is happening is pushing more and more of these common functionalities, right, which can be reused across multiple backend runners into the main Kubeflow pipeline engine, right? So something like, for example, pipeline persistence agent, which will be responsible in a more generic way to pull, the artifacts and the logs and persist them, right? I think yesterday there was a couple of questions around, the multi-user scenarios, right? So I do want to talk a bit about how Kubeflow handles it, and then by virtue of it, how Kubeflow pipeline is going to handle it, right? So this is something, some of our colleagues from, community members from Aricto, they have been championing this from the beginning and have done quite a great job of integrating bits of it. And now formally, this support is getting launched with the Kubeflow pipeline 1.0 as well, right? But the general Kubeflow authentication authorization mechanism is using Istio with a combination of DEX, and DEX in turn, right, can be then configured with any OIDC compliant, right, backend service, right? So whether it's you are using Google's authentication, IBM Cloud's authentication mechanism, LinkedIn, right, even GitHub authentication, right? You can configure DEX with multiple of these backend OIDC providers. And then Istio acts as an ingress gateway, right? And DEX acts as a plugin for Istio. So typically when your requests come there, then, Istio is the first one to actually intercept them. And if they're not, authenticated or authorized, it will then, send it to DEX. Based on DEX where it is configured, it will go and check whether it's a GitHub ID provider or, your favorite cloud IEM IIP providers. It will get and authorize, then get a JWT token. Once the JWT tokens are generated, then that's what is, then passed to Kubeflow to get this going. Now, one of the things which is important to understand in this case is that Kubeflow, by virtue of being architected as a Kubernetes native project, handles isolation at a namespace level, right? So that means when it says that you are authorized in construct of namespaces in particular, right? So there are certain namespaces to which you get access to, you are authorized to, and you are allowed to work only in those namespaces. Now, if you extend that, right, in the context of Kubeflow pipelines, right, one of the things which probably needs to happen more and is once, a user comes in and intercepted by the Istio gateway, and Istio then, ensures that you are the right person and what access rights you have working with DEX and the backend OIDC provider, and it gets these JWT tokens, then they are passed around, right? And that's where the next point of interception is the pipeline's API server. Now the pipeline API server is the one which is enforcing your authorization, right? So which data you should be able to see, right? Where or which namespaces you should be allowed to run your pipelines, right? Now that's being handled by at different levels, right? So for example, in the Kubeflow pipeline relational database, right, it will be the same DB holding all your pipeline runs, for example, but there will be filtering based on the namespaces to which you are authorized, right? So when you are querying, give me my pipeline runs, what you're getting is a filtered view of the pipeline runs which you have launched, right? So that's the current mechanism which is part of Kubeflow Pipeline 1.0. There are quite a few release candidates already ready. They are now being adapted. So the first integration, I would say, the first end-to-end integration is working with the Google GCP, and now they are being adapted to be made more generic in context of on-prem deployments. So our goal is that Kubeflow Pipeline 1.0 allows you to have this multi-user scenario. Now, one of the things which we are trying and ensure that it also gets in is that it's not only the isolation at the level of pipeline runs, right? So by default, currently, when you launch, if you're using multi-user Kubeflow pipelines, when you launch pipelines, you are able to see the pipelines in the namespaces. You are able to launch them, first of all, in your authorized namespaces, and you're only able to see the pipelines runs in your namespaces. But the overall, when you upload your pipeline, that's still open to the public, right? So that means anyone who uploads a pipeline by default, everyone else is able to see those pipelines. Now, there may be scenarios that you don't want to expose that, or you want to have an incremental process that, I first want to make sure that it's working for me. And if there is generic enough, I may want to promote it to the general larger public, right? So that's something, which we are ensuring and giving feedback so that, that also gets added. But any real-time run and the run logs and the run details, they're all filtered and on a per user basis. I think one of the things which I also want to highlight is one of our colleagues, Luciano. He and his team has done a great job, in launching Elyra, which is essentially allows you to drag and drop notebooks, right, and create pipelines out of them. And the backend engine, you can configure it to be Kubeflow pipeline and run it on Kubeflow pipeline. So if you have a bunch of notebooks flying in your organizations and you want to have a simple mechanism to create and orchestrate pipelines out of them, please check this out, this project. The next thing is essentially, where our focus is on the Kubeflow pipeline, right? So we are essentially, working as part of the mandates from Watson to enable Kubeflow pipeline in the Watson ecosystem, right? So have it go across Watson portfolio, which is Watson Studio, distributed deep learning training, Watson machine learning, Watson OpenScale, Watson knowledge catalog, data refinery, Watson Auto AI. So there are a lot of products which Watson has, and what this will allow is have a pipeline orchestration mechanism on top, which can, for folks who want to run in an automated fashion from end-to-end perspective, right? They can leverage this, right? So this is the goal where we are trying to get this integrated and productized, right? So now as part of this, right, as you can see, since this is going to be a core engine for the Watson AI pipelines, right? One of the goals which has been given to us to enable something like this, which goes through our data refinery, knowledge catalog, Watson machine learning, etc., is to have the engine based on Tekton, right? And the reason for Tekton being there are many folds, right? So I think trying first and foremost is the strategic alignment, right, between IBM and Red Hat, as well as Google, right, which is heavily contributing to Tekton on the cloud side, right? But we have made a decision on IBM cloud side that our pipelines, cloud native pipelines, will be based on Tekton. So it makes all the more sense for machine learning pipelines to essentially, be riding off that core engine. So that means, getting Kubeflow pipelines built on top of Tekton. And the second thing is OpenShift pipelines, which is available in the OpenShift platform as a core native service that's also running Tekton under the covers. And the third thing is, Tekton, by virtue of, having a more granular fine-grained distribution of different custom resource and custom resource definitions. For example, within the Tekton world, a task in itself has its own CRD. That means, task has its own life cycle. You can run tasks independent of pipelines. You can reuse them independent of pipelines. So that gives it a lot of, composability and reusability from that perspective, where you don't have to depend on the higher level pipeline CRD to do anything, right? And I think most of us who work in this field probably understand that, the heavy lifting of any pipeline task or any pipeline step happens in a task, right? So I think what Tekton did here was a great job of giving the task, the primary focus, and making it the independent part and having its own life cycle independent of the pipelines, right? Now you can combine multiple of these tasks in a pipeline. Tasks itself are made of steps, right? And these steps then, finally, when instantiated, you are seeing as running as containers within these pods. So when we started, we broke down this work in, I would say, three phases. Phase 1A, let's take the KFP SDK and the DSL, compile to Tekton along with Argo, and then, run it on Tekton directly. So that was done, delivered. And phase 2, instead of taking to Tekton directly, now take this compiled output to Kubeflow pipeline, API, and UI engine, and run it there, right? So again, this is done and delivered. Right, so we have now, 0.2 release of Kubeflow pipeline with Tekton backend, where you can essentially, use the Kubeflow pipeline, DSL, and SDK and compiler, compile and take it to Tekton. And again, as I said, right, great work by the team here: Christian, Tommy, Andrew, Kevin. You have been Fang, right, from our IBM systems team, right? They're all been contributing heavily. It was, to tell you, right, it was a humongous project to begin with, right? We started on it 6 months ago, and to ensure that, we, and the number of moving parts here, Tekton was in alpha at that particular point in time. And the amount of features which we needed to get going, right? So we literally had to drop down to a spreadsheet, map down feature by feature of the last count, like around 50 plus features, and then, figure out the corresponding functionalities in Tekton, figure out whether they exist. If they don't exist, how do we actually work with the Tekton community? Or, we align our own contributors on the Tekton side to contribute those features, right? So it has been a humongous effort for the last 6 months to get to the point where we are. And definitely, a lot of thanks to our committers on the Tekton side, Andrea, Preeti, Red Hats, Vincent, right? They've all been very helpful in terms of, getting us to the point where we have Kubeflow pipelines now working with Tekton, right? And then as you can see from these, DSL features which are listed here, and if you need more details, right, step-by-step detail, definitely hit Tommy on this. But all these different features, even when you look at it from a Kubernetes perspective, the Kubernetes resource of volume snapshot, or other things which we have been using, from the Argo perspective, right, they're being enabled, barring some caveats, right? So for example, the concept of loops is still in discussion in Tekton. There are some fundamental, I would say, philosophy differences, how loops should be handled, but that's moving forward. And as part of that, right, we are running, have created samples for some of the pipelines which we are running end to end. But, Christian also has put up a strong test infrastructure which goes and scans all the Kubeflow pipelines and runs them, compiles them, and then, does that initial apply on the KFP Tekton clusters to ensure that, they are good, right? But somebody definitely needs to now, ensure, as we are running this, and so far, we have taken quite a few pipelines and we are able to run them without any issues. So this is all, working good. Our Watson teams internally have been testing their pipelines. They're all working good. Now, I think beyond, the mapping of the DSL features to Tekton, the second effort where, we had to scratch a lot of our head was now going into the Kubeflow pipeline backend and ensuring that, Tekton is available as a first-class resource behind the API and the UI. Now, a lot of that code, right, as it exists today was, essentially hard-coded to Argo, right? So there were a lot of places in the code where, there is, which is written assuming, Argo is the one and only backend, right? So heavy dependency on the UI side with Argo with respect to the DAGs, etc. The assumption that you're coming with a single custom resource or a custom resource definition, right? So that all had to be reconciled. But again, as I mentioned, right, finally, after 6 months of extensive effort, right, we have this ready. So you're able to now, compile exactly using the same mechanisms, and then you get the same experience, right? So in this case, for example, you see the DAG for a Watson pipeline, which is doing a pretty simplistic job of running training using Watson Studio Deep Learning as a service and storing and deploying model on Watson machine learning. But this is backed by a Tekton, pipeline spec, which in pipeline run spec, right, which in general encompasses the task runs, the conditions, and everything one in all single document. The second thing, right, as I mentioned, exactly the same experience. So you get the logs, right, as you are used to into the Kubeflow pipeline dashboard engine. And then one of the things which I stressed in the beginning, right, which was the capabilities for artifact and lineage tracking, right, which becomes more and more important when you're putting these things in production, right? So I think initial experimental phases, you probably don't put a lot of emphasis on that, but as you start rolling your models from staging and towards production, the artifact and lineage tracking becomes really, really important, just to comply with compliance rules or having auditability practices in place. Again, as we talked yesterday, right, there is this end-to-end MNIST pipeline, right, which goes through all the Kubeflow components, including Cative with hyperparameter optimization, distributed training using the underlying TensorFlow distributed training job, and then deploying the model on KF serving, which is running all end-to-end using Kubeflow pipeline with Tekton backend. By the way, all of you who have provisioned cluster on IBM Cloud for the workshops, you are essentially running Kubeflow pipeline with Tekton backend, right? So now Tekton has its own dashboard, so you can go there as well and look at the pipeline runs and resources there as well. And I believe Tommy will show you quickly as well. So if someone is heavily in the Tekton community and they're just looking, okay, do I have a Python DSL to craft my pipelines, they can just use the native route, but behind the scenes, just use the Tekton dashboard as is, right? And it's pretty nice in the way that, it gives, as I mentioned, the primary focus on giving tasks their own independent status, and you can look at tasks and task runs independently of the pipeline. That's where, the real value of Tekton comes through. So I think I talked about, right, this is delivered, right? So now this was the amalgamation of phase 1 and phase 2, but there is a phase 3. And why phase 3 is important, right? So this is when we started having this discussion with Google initially. I literally went on, many meetings with the leadership on the Google side, vis-a-vis raising my concerns around, how Argo is tightly coupled right now with the Kubeflow pipeline, right? And why this work will make sure that, we are able to abstract it and make it generic, right? And one of the things which we wanted to do was an intermediate representation, right? Now, what this allows you is that your UI as well as backend gets tied to a standardized intermediate representation instead of, for example, to Argo or Tekton, or in future, you have another runner, for example, let's say Airflow, Apache Beam, right? I think the points resonated, right? And we discussed that, we are going to take this effort forward. So what is going to happen with Kubeflow pipeline 1.0 release, post 1.0 release, is that, we will be working closely with Google to align and standardize on that intermediate representation, right? So the goal here will be that, your SDKs, which is currently, the KFP SDK as is, compiles to an intermediate representation. That intermediate representation is what you are taking to the Kubeflow pipeline backend and UI engine. Now, another thing is, right, then the Kubeflow pipeline backend engine and UI is responsible for the DAG, which you should see is consistent. It's built on top of that intermediate representation. But then, there is intelligence in the backend to based on the end target, which is either Argo or Tekton, and as a bring your own runner, right? If somebody wants to implement another backend for Kubeflow pipeline, right? So that will be enabled. So that's the idea, right? And this is a work which will be, kicked off and moving into high gear into third quarter, right? Which will be essentially a lot of changes going into the Kubeflow pipeline engine to enable this, right? The other thing is, right, establishing some sort of conformance, right? So writing test and validation that the IR is being generated are consistent. Now there is also this concept of the fetcher, which is going to be introduced. So the fetcher, which is essentially then a high-level component which is responsible for pulling the data from the underlying running engines, right? So you need to pull the artifacts produced from the pods, or you need to pull the logs from the pods, right? So hopefully, with this concept of abstract fetcher, that can be generalized, and then have an implementation for each of these engines. So the timelines for this, right? The schema will be published around somewhere in Q3 timeframe. Then, IR-based KFP is being targeted for Q3. We will try as much as possible, right, to keep the Tekton effort in parallel at the same time, so as to align, so as to make sure, the version of Kubeflow pipeline which comes with an IR, Tekton is pre-integrated around the same time as Argo. And then, Q4 is when you probably have a more formal release. Another effort, right, where Kubeflow pipeline will be moving towards is the SDK and metadata convergence, right? So I think there is still, when you look at it from an SDK perspective, the longer term option is to merge the TFX and KFP SDK into one and move all the metadata, right, typically to ML metadata service. Right now, there is a mix in behind the Kubeflow pipeline backend engine between, how the data and metadata is stored between MySQL and MLMD, right? So the goal would be, to move forward and start compiling and standardizing on this one single approach, right? So I think you will probably see a lot of changes, happening into the Kubeflow pipeline beyond 1.0. But the good news, is 1.0 is coming out soon, and you have now also an option, to run Kubeflow pipelines with Tekton, right, as a backend engine. Another thing, right, which I would say is just stay tuned, right? There are quite a bit of exciting projects we are working within IBM. in terms of extending Kubeflow pipelines. There was a question yesterday about components and components registry and the APIs behind that, right? So there is quite a bit of stuff which we are working on, and we'll be working towards, moving them in open source soon, as and when the timeline allows us. With that, thanks. And these are the relevant links. And I believe, Tommy, you will be showing some demos, right, on this side.
Yep. Yes, no problem.
And maybe once Tommy is complete, right, we can take a couple of questions on that side. So I will try to answer, read through and answer the questions at the same, after the demos. Yeah. Go ahead, Tommy.
So for those of you who have like Kubeflow running, you're already sort of familiar with the Kubeflow pipeline dashboard over here. So I think before we get started, we could show you like the list of examples that you could find. So if you go to like github.com/kubeflow/kfptekton, under the samples, you will see a list of examples that you could try out using the Tekton backend. And we will have like a very detailed user guide on how you could compile, upload, and running the pipelines. So for today's demo, we're going to show you how to compile using the Tekton SDK, and then just upload using the UI interface and running it using the UI interface as well. So for examples, yesterday we have try out the flip coin examples, but the same example is also under the Tekton KFP Tekton repository. So you could take a look at the flip coin examples over here under /sample/flip coins. Then you could take a look at the actual source code in the Python DSL on how this pipeline is constructed. So this pipeline have like 3 functions that is converted into like container ops. One is for print, and one is for flipping coins, heads or tail. Another one is just generate a random number. So when we construct the pipelines, we also add like conditions on top of the task outputs. So we first flip a coin, and then we base on either head or tails. We use that condition to run different tasks underneath. And let's say for heads, we will create a random number generator from 0 to 9. And then based on that outcome, if it's greater than 5, we print out this string. If it's less than 5, we print out like heads is less than 5 string. And when we to compile this pipeline is pretty simple. So first, you just need to clone this repository, which I already have done. And in your terminal, install the KFP SDK. So you could just simply run pip install KFP Tekton, and that should install the SDK for you. And once you have it, you should be able to, let me clear up. So you should be able to see we're in the KFP Tekton repository, and we could just go into the samples, flip coins. You should be able to see the condition.py. And since at the very bottom in the main function, we already set up the compiler code. So we could just directly run this script using Python conditions.py. And once it compiles, you should be able to see a condition.yaml is generated, which is the Tekton equivalent Tekton YAML you could run on the Kubeflow dashboard. So now we have compiled the Python DSL into YAMLs. So let's go ahead and upload the pipelines. So here we could upload it by files. And under flip coins, we already just compiled right now. So we could just drag it over here. And you should be able to see it will populate the pipeline names for you. You can also change it to something else, like condition demo. And then click on create, or you could also add like links to your source code, so let other people know like where's you hosting the Python DSL. So for the demo, we just skip everything and just click on create. This is the pipeline you have seen from yesterday, where it's flip a coin based on the condition is generate a different random number and print out the statement. And you could also the workflow to run this pipeline is just very simple. Just click on create runs, and then you could pick on an experiment, and then click on start. And then once the pipeline start executing, you're just able to see task is being populated, and then see the output of this. So in this case, the output is the tail, and you can also see it from the log, and check the pause status and the event status. And since it's also tracked with the metadata writer, so you're able to see the artifacts being tracked as output. And from here, you could see these two containers being executed. One has failed the condition, so it's being skipped. So you could see this condition is being failed. So the rest of the pipeline for this part is being skipped. And for this generator, the condition has been met, so it will continue generate the rest of the steps under this pipeline random generator task. And then this pipeline random generator task output at 12. So that's why it would go ahead and create a print for container that shows you the number is less than 15. And that is a very simple example on how you could use the SDK to compile and upload from the user interface. The next pipeline I'm going to use is the MNES end-to-end example that Animesh has shown in the slide. So you could also see like the YAML is compiled into a Tekton. And to run this is you could just click on create run. And you could change any parameter you want to. And we could click on start. Since the pipeline will take a while, so I already ran something beforehand. So this pipeline is basically first launch a captive job that try to find the best hyperparameter values. And then once we get that values, we will extract it, like process it into like JSON, and then actually put it into a TF job for more iteration to train. And then that actual model is being stored into a persistent volume. And then once the model is being trained, it will store into the persistent volume. And then the inference task will just create inference service for KEF serving, and then use the model in the persistent volume to serve it, and you could try it out. So from here, you can also check like how the Lineage Explorer is being used. So you could we could first go back and see it launched a experiment, and then it's being used by the convergence experiment results. And then you see like those results is also being used by the train components. And for this pipeline, since we are trained it using Captive, you could also see like there should be a experiment being triggered over here. So this is the experiment we have just ran, and you could see these are all the hyperparameters. It has been fine, and then since it's trying to optimize the minimum loss, so it will pick like this set of hyperparameters. So in this case, it would be the first one with 0.028 TF learning rate and 16 TF batch size. And you want to learn about more on these examples, you could go to the KFP Tekton /sample / and E2E MS, where you actually go into details on how each step is being created. And everything is under a Jupyter Notebooks because we kind of parameterize some of the model names and user namespace. And under here, you could see how this complex pipeline is being created and using TF job as the backend to actually train this model. And once you run the pipeline, you're able to see like anything being ran is shown into the Tekton dashboard as well. So let's for the condition pipelines, you can see we first create a flip coin, and in Tekton, any condition that fail is, any condition that is not met, you consider as fail. So that's why you see a cross line. And then you can see like this, the other task status as well over here. And that's the end of the demo. Thank you very much.
Thanks, Tommy. So let's try and handle the questions, right, which haven't been handled, right? So from Jeffrey Griffith, how do people tend to manage the tight coupling between the pre-processing code that gets done in a pipeline and the pre-processing that needs to happen in a production inference? When you say a production inference, Jeffrey, your question is more like served model pipelines, which is something around the constructs of having a pre-processor and a post-processor when you're calling model predictions, right, to convert your end user inputs back to an input which your model understands. If it is referring to that, that's a bit of a separate domain, right? So Kubeflow Pipelines, provides functional capabilities to actually get your models deployed in production, right? So now once your models are deployed in production, and because you need to get that model deployed in production, you have a lot of pre-processing which you are doing on the data, you are changing models and validating models. But once it is deployed in production and running live, then the inference pipeline kicks off, right? So from that perspective onwards, it's the specifics of a domain like KF serving, which we are going to talk in one of the subsequent sessions, where if you want to have a preprocessor which translates end user images, for example, images to tensors before calling your models, and then takes the tensors and translates them back to a text, right? So that's part of KF serving. That's already available in KF serving. The next step, which is being enabled, is the multi-model graphs, right? What some of us may call model pipelines, but the core idea that the capability to chain the outputs from one model to another model or a set of models, and then take that output, combine it with another model output, right? So that's a capability, right, which is being designed as part of the KF serving, right? So the inference pipelines are a domain of KF serving. I hope that answers your question. Jim is asking, is the Tekton implementation supported on Power? I will have to defer on that. I will have to get that answer right. But typically, this is one of those things where if it is not right now, it would be very soon, given the strategic IBM and Red Hat push on Tekton, right? Does CADM run only on notebooks? It can be, so that question is then converted with Kale. Okay, so one of the projects which we didn't talk about, which is also part of the Kubeflow pipeline ecosystem, is Kale, right? What Kale allows you to do is essentially annotate the cells in your notebook with their specific annotation, and that again is our community partners from Erecto. They have been doing a great job. They are mostly behind Kale, so that allows you to annotate their cells, and then you can launch those individual cells as different steps of a pipeline, right? But it works, as far as I'm aware, this works only in the context of a notebook, right? So Josh, I don't know, if you're here and if you want to provide any more inputs on that Kale project.
Yeah, can you hear me?
Yes.
So yeah, we've invested quite a bit into Kale, and the latest workflow automation that we have provided does provide ease of use when you're trying to build and deploy a model using Kubeflow pipelines. It reduces the need for the data scientist to build a Docker container from their code, and then for each pipeline step, and then upload each of those containers into a repo, and then to write the pipeline's domain-specific language, the DSL, to string all those containers together, and then upload that into Kubeflow pipelines and run it. All those steps have been automated through Kale. So that's a big savings for folks that don't want to learn Kubernetes, they don't want to build Docker containers, and they don't want to learn the Kubeflow pipelines DSL coding. And the other piece, Animesh, I'm not sure that you're aware, we've started to integrate this through an SDK into IDEs like VS Code. So Kale works and is primarily delivered today through Notebook. But if you're using an IDE, Kale will also have a way to work with that by the same way you talked about annotating your code that needs to go into each pipeline step. That will work inside of just regular code in a regular IDE like VS Code.
That's awesome. That's great.
Yeah, so hopefully that gives you a little bit. We've got some good tutorials that people can walk through. And I think the hands-on, like you're doing here, is very valuable for people to see it rather than just hear about it or see slides. So more than willing to help people there.
Sure. So if you all, as I mentioned, right, I mean, I expect this, Kubeflow Dojo to have, more spin-offs, something more targeted towards, the OpenShift ecosystem, something more targeted, the sort of projects we haven't covered in detail, like Fairing, Kale, and others, right? So definitely, put in your request and we can, have a subsequent one where we go into the projects we don't cover. There is another question around TFX metadata server. What about TFX metadata server? I mean, I don't know if I understand the context, right? But the goal, I mean, as I talked about, right? So the metadata story in both TFX and KFP is going to be backed by MLMD, right? That's the model management database, and that's where all the metadata will be going, right? So if you're following the queues, right, what is happening is that KFP and TFX are moving towards a convergence, right? So a common SDK, a common backend for metadata collection, and over a period of time you will see this convergence, happening more and more. And I hope that answers that question. What might be in transformation versus what's in a pipeline? Did I answer that question, Jeff? I mean, if you're happy, just say, right? If you're happy with the answer, otherwise, we can definitely follow on offline. Is there a KFP Tekton versus KFP core feature comparison available? Yes, if you go to the KFP Tekton repo, right? And I believe, Tommy showed you earlier. So if you go to github.com/kubeflow/KFP Tekton. and probably the one which you will be interested in is the available features and implementation details, right? So this one documents all the features, right, which have been implemented as part of this implementation, right? And there are features, right, which have certain limitations, right? So if you are willing to dive into these details, please go there. Okay. From question from Sean, is there a question or an answer? Given one actual ML project, I want to deliver a notebook-centric UX for data scientists. The reality is needs to jump among notebooks, CLI, local Docker, which is not ideal. Is there any planned direction around this? It needs to jump among notebooks, CLI, local Docker image building. So I think there is capability in Kubeflow pipelines where you can have simple Python functions converted to Docker images directly. You don't need to have pre-built Docker images, right? So for example, there is a provider and there is a consumer, right? So if you're a provider of the Kubeflow pipeline platform, right, you have created certain components which are pre-built Docker images. And most of your data scientists, they can just use the Python SDK, use those components, right? So that covers 70% of your mass. Now there will be 20% who would want to bring custom components, right? Now custom components, you can, yes, if you want to bring a custom component, that means, behind the scenes that translates to a custom Docker image. But as I mentioned, if your components are lightweight enough, you are doing simple Python tasks, Kubeflow pipeline DSL, gives you a capability to just, define simple Python functions, which behind the scenes, get converted to a custom Docker image and run on that, right? So the correct way to say is, they get essentially launched at runtime on a Docker image, right? Without you needing to create a custom component Docker image for that. So that's available, right? But yeah, if it is something which is doing, very heavy duty task where you probably have long range jobs, etc., you might need to create a custom component. But yeah, I think there will be, use cases where, totally custom components, require users to build their own backend Docker images. Okay. Is it matured KFP Tekton? Do we need Jenkins X also with Tekton? So Rakesh, the question is, it essentially translates from our perspective, yes, right? It's the same Kubeflow. If we call Kubeflow pipeline mature at this point, which is at version 1.0 coming soon, it's the same with the Tekton backend, right? Now, as I mentioned, capabilities like loops, right, for example, is not available, but for what it is available, it's essentially, having that maturity level of what Kubeflow pipeline and Tekton provides to you. So Tekton itself is a project which is in beta, right? So there is not a 1.0 of Tekton at this point, right? So unless, you see the longer term benefits of Tekton and it's reaching there soon, as I mentioned, right? We are already having products which are running on Tekton, both on IBM cloud side as well as OpenShift, right? So we have based our CI/CD products on that. We are running all currently the Kubeflow pipelines being developed inside Watson. They're all leveraging and running on top of Tekton backend, right? So it's definitely ready for you to consume. Now, if there are issues and gaps which you find, let us know, right? We'll continue to improve that. Okay. Did we cover all the questions? If there is more, please keep on pinging us, right? Or use the Kubeflow Dojo Slack channel and we'll continue answering there, right? What about TFX, KFP, and KFP Tekton? What about them? I think if you watch the presentation, right, I sort of went into that in my last few slides, right? What is happening, right? There is, at this point, there is an SDK and metadata convergence, right? So the same metadata collection mechanisms behind both Kubeflow pipeline and TensorFlow pipeline, the same SDK. So you will get a single SDK, you will get the same metadata backend, right, MLMD. The other thing is, right, the concepts, if you're using TensorFlow extended, you're probably using the concepts of driver, executor, and publisher, right, which is more working around the constructs of a tightly defined schema, which is strongly typed. And because, the inputs and the outputs of the steps are strongly typed, because of that, you are able to get more automation, right? So those will be made available as well into KFP, right? And the only thing is, one thing which we have stressed is that we don't want to apply to everything, right? So your custom Kubeflow pipeline components without strong typing will continue to work, but if you are adhering to the strong typing mechanisms of TFX pipelines, you will get the capabilities of driver, executor, and publisher. So I think one thing which is not explicitly mentioned, but implicitly implied, if you see the longer term convergence, as I mentioned, Kubeflow pipelines and TFX are moving towards that longer term convergence. Hopefully that, answers that question. Okay. Looks like we are good. And as I mentioned, right, please bring up your questions, if you have more, and we can use this forum or the Kubeflow Dojo Slack channel to continue answering them. With that, thanks everyone. We'll probably take a break. Let me look at the schedule.